What if the next frontier for humanity isn't in the stars, but beneath the waves? For centuries, we've looked to the skies, dreaming of life beyond Earth. But what if the answer to our survival and our future lies in the vast, unexplored depths of our oceans? Today, we're diving into a world where cutting-edge technology is turning science fiction into reality. Imagine underwater cities powered by renewable energy, self-sustaining habitats thriving in the darkest depths, and even the potential to extend these innovations to other planets. This isn't just about exploration, it's about redefining how we live, work, and survive in an era of climate change and resource scarcity. From revolutionary underwater architecture to mind-blowing extraterrestrial colonies, we're about to uncover the technologies that could make living underwater and beyond not just possible but essential. So, are you ready to explore the future of humanity's next great adventure? Let's dive in. Picture this, a sprawling city beneath the waves, its glowing domes rising like bioluminescent beacons in the deep blue. Inside, lush gardens thrive under artificial sunlight, while sleek underwater pods glide silently between structures, connecting homes, workplaces, and recreational spaces. This isn't just a scene from science fiction, it's a vision of what underwater cities could become. These metropolises of the deep are designed to be self-sustaining, with advanced ecosystems that recycle water, produce oxygen, and grow food, all while minimizing environmental impact. The idea of living underwater isn't new. Jules Verne's 20,000 Leagues Under the Sea captured imaginations over a century ago, painting a picture of life beneath the ocean surface. Today, that dream is closer to reality than ever. With Earth's population growing and urban areas becoming increasingly crowded, underwater cities offer a compelling solution. By expanding human habitation into the oceans, we could alleviate pressure on land resources, create new opportunities for innovation, and even protect communities from natural disasters like hurricanes and rising sea levels. But the benefits don't stop there. Underwater cities could also play a key role in combating climate change. By harnessing the ocean's natural cooling properties and relying on renewable energy sources like tidal and wave power, these habitats could operate with a fraction of the carbon footprint of traditional cities. Imagine a future where urban centers not only coexist with marine life but actively contribute to its preservation, with artificial reefs and conservation zones built into the design. Of course, building a city beneath the waves is no small feat. It requires groundbreaking technology and innovative engineering breakthroughs that are already happening today. From materials that can withstand immense pressure to systems that generate breathable air and clean water, the tools to make underwater living possible are being developed right now. And as we'll explore next, these advancements are pushing the boundaries of what we once thought was impossible. Building a home beneath the waves is no small feat. It's not just about diving deep, it's about rethinking the very foundations of construction itself. One of the biggest challenges, designing materials that can survive the crushing pressure, relentless corrosion, and constant wear of the ocean. Enter graphene, a supermaterial that's stronger than steel, yet lightweight and flexible. This wonder material is being explored for everything from structural reinforcements to waterproof coatings, offering a game-changing solution for underwater durability. But graphene isn't the only star in this engineering show. Self-healing concrete is another groundbreaking innovation. Picture this. Tiny capsules embedded within the concrete that release a healing agent when cracks form, effectively repairing themselves over time. This technology could revolutionize underwater habitats, ensuring they remain stable and secure for decades. Then there's the design itself. Building underwater isn't like constructing on land. The logistics are far more complex, which is why modular structures have become a go-to solution. These prefabricated sections can be assembled like underwater Lego blocks, reducing the need for intricate construction work at extreme depths. And let's not forget 3D printing, a technology that's already making waves quite literally. Imagine robotic arms layering materials into intricate, pressure-resistant shapes, creating habitats that are both functional and futuristic. These designs aren't just theoretical either. Real-world projects like the Aquarius Reef Base off the coast of Florida and Japan's ambitious ocean spiral concept are proving that underwater living isn't just possible, it's happening. But even the most advanced materials and designs are only part of the story. What keeps these habitats functional day in and day out? That's where life support systems come into play, ensuring everything from breathable air to clean water for the inhabitants. And that's exactly where we're headed next. Living underwater isn't just about building structures that can withstand the pressure of the deep, it's about creating environments where humans can thrive indefinitely. At the heart of this challenge are life support systems, the unsung heroes that keep the air breathable, the water drinkable, and the energy flowing. Let's break down how these systems work and why they are so groundbreaking. First, consider air filtration. In underwater habitats, every breath you take is made possible by advanced systems that scrub carbon dioxide from the air and replenish it with oxygen. These aren't your average air purifiers. They're highly efficient machines designed to operate in extreme conditions, ensuring that the air stays fresh and safe even miles beneath the surface. But air is just the beginning. Water recycling is equally critical. Imagine turning every drop of water you use, from drinking to showering, into a resource that can be reused endlessly. Cutting-edge filtration and purification technologies make this possible, turning wastewater into clean, potable water in a closed-loop system that mimics nature's own cycles. Energy is another cornerstone of underwater living. Unlike on land, where we often rely on fossil fuels, underwater habitats can tap into the ocean's vast renewable energy potential. Think about it, the ocean is a powerhouse of energy, from the relentless motion of waves to the steady flow of currents. Underwater turbines and wave energy converters can harness this movement, providing a constant, sustainable source of power. And let's not forget thermal gradients, differences in water temperature at varying depths, which can be used to generate energy through ocean thermal energy conversion, or OTEC. These technologies not only power the habitat but also reduce the need for external energy sources, making underwater living more self-sufficient. But what truly sets these systems apart is their integration with biotechnology. Scientists are developing closed-loop ecosystems where plants, algae, and microorganisms work together to recycle waste, produce oxygen, and even grow food. These systems are inspired by Earth's natural processes, creating miniature biospheres that can sustain life without relying on constant resupply from the surface. It's like having a tiny, self-sustaining Earth right there in the depths of the ocean. And here's where things get even more fascinating. The same systems designed for underwater living could be the key to surviving in space. The challenges of living underwater, limited resources, isolation, and the need for self-sufficiency are strikingly similar to those we'd face on a space station or a colony on Mars. By perfecting these technologies in the ocean, we're not just unlocking the secrets of underwater living, we're paving the way for humanity's future among the stars. Artificial intelligence is quietly becoming the backbone of life beneath the waves, transforming how we live, work, and thrive in underwater habitats. Picture this, a self-sustaining underwater city where AI systems constantly monitor the structural integrity of habitats, ensuring they can withstand the immense pressure of the ocean depths. These systems don't just react to problems, they predict them, Using advanced algorithms, AI can analyze data from sensors embedded in the habitat's walls, detecting even the tiniest signs of wear or stress long before they become critical. This isn't just about safety, it's about creating a living environment that feels as reliable as a home on land. But AI's role doesn't stop there. Managing resources in an underwater habitat is a delicate balancing act, and AI is the ultimate multitasker. From regulating oxygen levels to optimizing energy use from renewable sources like tidal and solar power, these intelligent systems ensure that every resource is used efficiently. Imagine a network of AI-controlled systems that can adjust lighting, temperature, and even food production based on real-time data, all while minimizing waste. It's like having a smart home, but one that's designed to keep you alive in one of the most challenging environments on Earth. Then there's the role of robotics, which are becoming indispensable in underwater living. AI-powered robots are taking on tasks that are too dangerous or tedious for humans. They inspect and repair infrastructure, explore uncharted areas of the ocean floor, and even assist with scientific research. Some robots are even being designed to provide companionship, helping to combat the isolation that can come with living in such a remote environment. These robotic companions might not be human, but their ability to interact, learn, and adapt makes them invaluable in creating a sense of connection in the deep. Living underwater isn't just a physical challenge, it's a psychological one too. The isolation, the darkness, and the constant pressure can take a toll on mental health. This is where AI steps in again, offering solutions like virtual reality environments that simulate natural landscapes, or AI-driven therapy programs tailored to the unique stresses of underwater life. By addressing both the physical and emotional needs of inhabitants, technology is helping to make underwater living not just possible, but truly livable. As we dive deeper into the possibilities of AI in underwater habitats, it's clear that this technology is more than just a tool, it's a lifeline. It's reshaping how we think about life beneath the waves, turning what once seemed like science fiction into a tangible, sustainable reality. Living underwater might sound like a dream come true for some, but let's not overlook the psychological and social challenges that come with it. Picture this: you're surrounded by water on all sides, living in a confined space far from the natural rhythms of life on land. Over time, the isolation and lack of wide open spaces can take a toll on mental health. Feelings of claustrophobia or loneliness could become significant hurdles for residents of these futuristic habitats. This is where technology steps in as a lifeline, literally. Virtual reality and immersive technologies could play a crucial role in combating these challenges. Imagine slipping on a VR headset and instantly stepping into a lush forest or a bustling cityscape, even while you're deep beneath the waves. These digital escapes could help alleviate the sense of confinement, offering a mental reset and a way to stay connected to the world above. It's not just about distraction, it's about creating a sense of normalcy and balance in an otherwise alien environment. But technology alone isn't enough. Building strong social structures and fostering a sense of community will be vital for long-term well-being. Think about it. In such isolated settings, the people around you become your extended family. Shared spaces for socializing, collaborative projects, and regular group activities could help residents feel connected and supported. After all, humans are social creatures, and a thriving community might just be the key to making underwater living not only sustainable but also enjoyable. Now, while we're on the topic of thriving, let's pivot to the economic potential that these underwater habitats could unlock. Beyond the psychological and social aspects, there's a whole world of opportunity waiting to be explored, industries that could flourish beneath the surface, shaping a new era of innovation and growth. The ocean floor holds more than just mysteries, it's a treasure trove of economic potential waiting to be unlocked. Imagine a world where underwater habitats aren't just places to live but hubs of thriving industries, from mining rare minerals to cultivating sustainable seafood. One of the most promising opportunities lies in underwater mining, where robots and advanced machinery could extract valuable resources like cobalt, nickel, and rare earth metals, materials essential for everything from smartphones to renewable energy technologies. But here's the exciting part. These operations could be designed to minimize environmental damage, using precision tools to avoid disrupting fragile ecosystems. It's a delicate balance, but one that could redefine how we think about resource extraction. Aquaculture or underwater farming is another game changer. Picture vast underwater farms growing seaweed, shellfish, and even fish in controlled environments. These farms could provide a sustainable source of food, reducing the strain on overfished oceans while feeding a growing global population. Innovations like vertical farming systems beneath the waves could maximize space and efficiency, creating a new era of food production that's both eco-friendly and economically viable. And let's not forget the allure of underwater tourism, luxury habitats offering breathtaking views of marine life, coral reefs, and even submerged cultural heritage sites. This isn't just a niche market, it's a multi-billion-dollar industry waiting to flourish. But the economic potential of underwater habitats isn't just about commerce, it's also about science. These habitats could serve as living laboratories, allowing researchers to study marine biology, climate change, and oceanography in ways that were once impossible. Imagine scientists living and working on the ocean floor, uncovering new species, monitoring ocean health, and gathering data to combat rising sea levels and warming waters. The knowledge gained here could have far-reaching implications, not just for Earth but for future missions to other water-rich worlds like Europa or Enceladus. And that's where things get even more fascinating. The technologies developed for underwater habitats, life support systems, sustainable energy solutions, and advanced robotics could be the foundation for exploring extraterrestrial oceans. The lessons learned beneath our waves might one day help us navigate the icy seas of distant moons, expanding humanity's reach into the cosmos. So while the economic opportunities beneath the waves are immense, their impact could ripple far beyond our planet, shaping the future of exploration and innovation. Living underwater and venturing into space may seem like entirely different endeavors, but they share more in common than you might think. Both environments push the boundaries of human survival, forcing us to confront extreme conditions, limited resources, and the need for self-sustaining systems. The challenges of building a home beneath the waves, where pressure, isolation, and the scarcity of breathable air are constant threats, mirror the obstacles we face in creating habitats on the Moon or Mars. This connection isn't just theoretical, it's practical. Technologies designed for underwater living, like advanced water filtration systems, energy-efficient lighting, and closed-loop life support, could serve as blueprints for extraterrestrial colonies. Take, for example, the need for reliable oxygen generation. Underwater habitats often rely on electrolysis to split water into hydrogen and oxygen, a process that could be adapted for use in space. Similarly, the compact, energy-efficient designs of underwater greenhouses essential for growing food in confined, resource-scarce environments could inspire agricultural systems for lunar or Martian bases. Even the psychological challenges of living in isolation, whether in the depths of the ocean or the vastness of space, demand similar solutions, from virtual reality environments to communication systems that combat loneliness. Earth's oceans, in many ways, are the perfect testing ground for these innovations. They provide a controlled yet extreme environment where we can refine technologies before deploying them millions of miles away. By tackling the challenges of underwater living first, we're not just preparing for a future beneath the waves, we're building the foundation for humanity's next giant leap into the stars. And as we look to the cosmos, the lessons we learn here on Earth could be the key to thriving in the unforgiving expanse of space. This brings us to the concept of space habitats, structures designed to sustain human life far beyond our planet. Just as underwater habitats must shield their inhabitants from the crushing pressure and cold of the deep sea, space habitats must protect against the vacuum of space, radiation, and extreme temperatures. The parallels are striking, and the solutions may be closer than we think. Living underwater might seem like the ultimate frontier, but let's take a moment to look even further into space. Space habitats are the next logical step in humanity's quest to expand beyond Earth, and they come in many forms, from orbiting stations like the International Space Station to ambitious plans for lunar bases and even Mars colonies. These habitats are designed to sustain life in the most extreme environments imaginable, where every breath, every step, and every moment requires careful planning and cutting-edge technology. At first glance, living underwater and living in space might seem worlds apart, but they share surprising similarities. Both environments are hostile to human life without artificial support. In space, the lack of gravity, exposure to cosmic radiation, and the psychological challenges of isolation are major hurdles. Underwater, while gravity remains constant, the pressure, limited resources, and isolation create parallel challenges. The key difference lies in gravity. Space habitats often rely on microgravity or simulated gravity systems, whereas underwater habitats are firmly anchored to Earth's natural forces. Despite these differences, both environments push us to rethink how we live, work, and thrive. Space habitats, for example, are crucial stepping stones for human exploration and colonization. They serve as testing grounds for technologies that could one day support life on Mars or beyond. Imagine a future where lunar bases become hubs for scientific research, mining, and even tourism, or where orbiting stations act as waypoints for deep space missions. These habitats aren't just about survival, they're about creating a sustainable future for humanity among the stars. So, what makes space living possible? It's a combination of innovative technologies and bold engineering. Artificial gravity systems, advanced life support, and radiation shielding are just a few of the critical components. And let's not forget the role of robotics and AI, which can handle tasks too dangerous or tedious for humans. These technologies are not only enabling space habitats, but also inspiring breakthroughs in other fields, from medicine to energy. The lessons we learn in space could one day transform life on Earth, just as the innovations from underwater habitats are already shaping our oceans. As we look to the stars, it's clear that space habitats are more than just science fiction. They're the next chapter in our story as explorers. Whether it's a lunar base or a Mars colony, these habitats represent the ultimate test of human ingenuity and resilience. And just like underwater living, they remind us that the challenges of the unknown are always worth tackling. With that in mind, let's dive deeper into the technologies that make these space habitats possible, because the future of humanity might just depend on them. As we venture beyond Earth, the technologies required to create and sustain space habitats become the backbone of humanity's extraterrestrial future. Think about it, these habitats aren't just futuristic homes. They're entire ecosystems designed to keep humans alive in one of the most hostile environments imaginable. One of the biggest challenges, radiation. In space, without Earth's protective atmosphere, astronauts are exposed to cosmic rays and solar radiation that can be harmful over time. To combat this, scientists are developing advanced radiation shielding materials like hydrogen-rich polymers and even water-based barriers, which can absorb or deflect harmful particles. These innovations are critical for ensuring long-term safety for anyone living off-planet. But radiation is just the beginning. Life support systems are the unsung heroes of space habitats. These systems must recycle air, water, and waste with near-perfect efficiency, creating a closed-loop environment that mimics Earth's natural cycles. Imagine a habitat where every drop of water is purified and reused, where carbon dioxide is converted back into breathable oxygen, and where waste is transformed into usable resources. It's a delicate balance, but breakthroughs in filtration, chemical processing, and energy management are making these systems more reliable than ever. Then there's the question of food. Sustainable agriculture in space is a game changer. Instead of relying solely on pre-packaged meals, space habitats could grow fresh produce using hydroponics or aeroponics methods that don't require soil and use minimal water. Picture a greenhouse on Mars, bathed in artificial sunlight, filled with rows of leafy greens and vibrant vegetables. These systems not only provide nutrition but also boost morale, offering a taste of home in the vastness of space. Building these habitats is no small feat, and that's where 3D printing and in-situ resource utilization come into play. Rather than hauling massive materials from Earth, future missions could use 3D printers to construct habitats layer by layer using materials found on the Moon or Mars. This approach, known as in-situ resource utilization, could drastically reduce costs and logistical challenges. Imagine robotic arms assembling habitats from lunar dust or Martian regolith, creating structures that are both durable and adaptable. And speaking of robots, artificial intelligence and robotics are set to play a pivotal role in managing these habitats. AI systems could monitor environmental conditions, adjust life support systems, and even predict maintenance needs before problems arise. Robots, meanwhile, could handle repairs, assist with construction, and perform tasks too dangerous for humans. Together, these technologies create a seamless, self-sustaining environment that allows humans to focus on exploration and discovery. Yet, as we push the boundaries of technology, we can't overlook the human element. Living in space isn't just about surviving, it's about thriving. The psychological and social challenges of isolation, confinement, and being far from Earth are just as important to address as the technical ones. How do we create spaces that foster mental well-being? How do we build communities that support collaboration and resilience? These questions remind us that the future of space living isn't just about the tools we build, it's about the lives we design around them. Living in space isn't just about surviving the physical challenges, it's also about thriving mentally and emotionally in an environment that's inherently isolating. Imagine being thousands of miles from Earth, confined to a small habitat with limited social interactions. The psychological toll of such an existence can be profound. Astronauts often report feelings of isolation, heightened stress, and even a sense of detachment when they look back at Earth, a phenomenon sometimes called the overview effect. While seeing our planet from afar can inspire awe, it can also amplify feelings of loneliness and insignificance, especially during long missions. But here's where technology steps in as a lifeline. Virtual reality, for example, is being explored as a way to combat the monotony of space life. Imagine strapping on a VR headset and suddenly being transported to a bustling city street, a serene forest, or even a simulated family gathering. These immersive experiences can help astronauts feel connected to Earth and provide a mental escape from the confines of their spacecraft. Similarly, advanced communication technologies are bridging the gap between space and home. Real-time video calls, holographic messages, and even AI-driven companionship systems are making it easier for astronauts to stay emotionally grounded. Building a sense of community is equally critical. In space, habitats fostering teamwork and camaraderie isn't just nice to have, it's essential for survival. International collaboration plays a huge role here. When astronauts from different countries work together, they bring diverse perspectives and problem-solving approaches, which not only strengthens the mission but also creates a richer social environment. This spirit of global cooperation is a reminder that space exploration is a shared human endeavor, one that transcends borders and unites us in our quest to explore the unknown. Of course, the psychological and social challenges of space living are deeply intertwined with the economic opportunities that come with it. As we look ahead, the growing space economy, from asteroid mining to space tourism, offers new ways to fund and sustain these habitats. But more than that, it opens the door for more people to experience space, breaking down the barriers of isolation and making it a more communal frontier. The more we invest in understanding and addressing the mental health challenges of space, the closer we get to making it not just a place to survive, but a place to thrive. What if the next trillion-dollar industry wasn't on Earth, but in the stars? Space is no longer just the final frontier, it's becoming the next economic frontier. From mining asteroids for rare metals to building luxury space hotels, the opportunities for growth and innovation are as vast as the cosmos itself. Let's start with space mining. Asteroids are like floating treasure chests packed with platinum, gold, and other rare materials that are scarce on Earth. Companies are already working on spacecraft designed to extract these resources, which could revolutionize industries back home, from electronics to renewable energy. Imagine a future where the materials in your smartphone or electric car battery come from a rock floating millions of miles away. But it's not just about mining. Space tourism is taking off, literally. Companies like SpaceX and Blue Origin are paving the way for civilians to experience the thrill of leaving Earth's atmosphere. And this isn't just a joyride for the ultra-wealthy, it's a stepping stone toward making space travel more accessible. Think about how air travel evolved from a luxury for a few to a routine mode of transportation. Space tourism could follow a similar path, creating jobs, sparking innovation, and inspiring a new generation of explorers. Then there's manufacturing in space. The unique conditions of microgravity open up possibilities we can't replicate on Earth. Scientists are experimenting with creating ultra-pure crystals, advanced alloys, and even human organs in space. These breakthroughs could lead to new medical treatments, stronger materials for construction, and technologies we can't yet imagine. Space habitats aren't just homes for astronauts, they're laboratories for cutting-edge research. From studying the effects of zero gravity on the human body to observing distant galaxies without the interference of Earth's atmosphere, these habitats are unlocking answers to some of humanity's biggest questions. But as we look to the stars, we can't ignore the ethical questions that come with expanding our reach. What happens when we start mining asteroids? Who owns the resources in space? And how do we ensure that the benefits of these industries are shared equitably? These are questions we'll need to answer as we venture further into the cosmos. And speaking of ethics, the same considerations apply to living underwater. Who has the right to explore and exploit the ocean's depths? How do we balance progress with protecting the delicate ecosystems beneath the waves? Whether we're looking up at the stars or diving into the deep blue, the future of humanity's expansion comes with responsibilities we can't afford to ignore. As we venture deeper into the possibilities of living underwater and beyond, it's crucial to pause and reflect on the ethical challenges that come with these groundbreaking technologies. After all, innovation doesn't exist in a vacuum. It impacts ecosystems, societies, and the very fabric of our shared humanity. So, what are the key ethical dilemmas we need to address as we push the boundaries of where and how we live? One of the most pressing concerns is the environmental impact of underwater habitats and space colonies. Building and maintaining these structures could disrupt delicate marine ecosystems or contribute to space debris, creating long-term consequences for our planet and beyond. For instance, underwater construction might disturb coral reefs or marine life, while mining resources from the ocean floor could lead to habitat destruction. Similarly, in space, the extraction of minerals from asteroids or the moon raises questions about sustainability and the preservation of celestial environments. These challenges remind us that progress must be balanced with responsibility, ensuring that our advancements don't come at the expense of the natural world. Another ethical consideration revolves around resource allocation. Who gets access to these futuristic habitats, and how do we ensure fairness? The development of underwater cities and space stations requires significant investment, which could lead to a scenario where only the wealthiest nations or individuals can afford to participate. This raises concerns about inequality, as access to these technologies could widen the gap between the privileged and the underserved. To prevent this, international cooperation will be essential. By working together, nations can establish frameworks that prioritize equitable access and shared benefits, ensuring that these innovations serve humanity as a whole rather than a select few. This brings us to the importance of global collaboration and regulation. Without a unified approach, the rush to explore and inhabit new frontiers could lead to conflicts over territory, resources, and control. History has shown us the consequences of unregulated exploration. Think of the colonial era or the exploitation of natural resources in the past. To avoid repeating these mistakes, we need robust international agreements that govern the use of underwater and space technologies. These frameworks should emphasize sustainability, fairness, and the collective good, creating a foundation for responsible innovation. But regulations alone aren't enough. Education and public awareness play a vital role in shaping the future of these technologies. By fostering a deeper understanding of the ethical implications, we can empower individuals and communities to advocate for responsible practices. Imagine a world where students learn about the importance of protecting marine ecosystems alongside the science of underwater habitats, or where public campaigns raise awareness about the need for equitable access to space technologies. Through education, we can cultivate a generation of innovators and leaders who prioritize ethics alongside progress. As we look ahead, it's clear that the ethical considerations of living underwater and beyond are as complex as the technologies themselves. But by addressing these challenges head-on through environmental stewardship, equitable resource distribution, global cooperation, and public education, we can ensure that these advancements truly benefit all of humanity. The future is not just about building new worlds, it's about building a better one together. One of the most powerful tools we have in shaping the future of underwater and space living isn't a piece of technology, it's education. Think about it, every groundbreaking innovation starts with a spark of curiosity, and that spark often comes from learning. As we push the boundaries of what's possible, we need to ensure that the public not only understands these advancements but feels inspired to contribute to them. Schools, media, and public outreach programs are the bridges that connect these futuristic ideas to the people who will one day make them a reality. Imagine a classroom where students aren't just reading about the oceans or outer space, but are actively designing habitats for these environments. Picture documentaries and social media campaigns that don't just showcase the wonders of underwater cities or lunar bases, but also explain the science and engineering behind them. These efforts can ignite a passion in young minds, turning today's students into tomorrow's pioneers. And it's not just about inspiration, it's about preparation. The challenges of living in extreme environments require a deep understanding of biology, engineering, and environmental science, and that knowledge starts with education. But education alone isn't enough. Public awareness plays a crucial role in shaping the future of these technologies. When people understand the potential and challenges of underwater and space living, they're more likely to support research, funding, and policies that drive these innovations forward. Media outlets, for example, can play a pivotal role by presenting accurate, engaging stories that balance excitement with realism. Documentaries, podcasts, and even viral social media content can help demystify these concepts, making them accessible to a broader audience. Of course, none of this happens in a vacuum. Governments and private companies are key players in driving these advancements. They're the ones funding research, building infrastructure, and creating policies that enable progress. Take, for instance, the way space agencies collaborate with educational institutions to develop programs that train the next generation of astronauts and engineers. Or how tech companies invest in underwater robotics, creating opportunities for students and professionals alike to explore new frontiers. These partnerships between public and private sectors are essential, ensuring that the momentum behind underwater and space living continues to grow. By combining education, public awareness, and strategic collaboration, we're not just building habitats, we're building a future where humanity thrives in places we once thought impossible. And that future starts with the choices we make today, from the lessons we teach in classrooms to the stories we share with the world. When it comes to pushing the boundaries of human exploration, whether beneath the waves or among the stars, no single entity can do it alone. Governments and private companies have increasingly joined forces, pooling resources, expertise, and ambition to tackle some of the most audacious technological challenges of our time. Take, for example, NASA, groundbreaking collaborations with SpaceX and Blue Origin. These partnerships have not only revitalized space exploration, but also set a precedent for how public and private sectors can work together to achieve what once seemed impossible. SpaceX's reusable Falcon rockets, for instance, have drastically reduced the cost of launching payloads into orbit, thanks to NASA's early support and funding. Similarly, Blue Origin's advancements in rocket propulsion and landing systems have been accelerated through government contracts and shared research initiatives. These successes highlight a crucial truth: innovation thrives when public institutions and private enterprises align their goals. Governments bring long-term vision and substantial funding, while private companies inject agility, competition, and a relentless drive for efficiency. But it's not just about space. The same model is proving transformative for underwater technologies. Companies like OceanGate and governments worldwide are collaborating to explore the depths of our oceans, mapping uncharted territories and developing sustainable solutions for deep-sea mining and energy extraction. These partnerships are paving the way for a future where underwater habitats and space colonies aren't just the stuff of science fiction, they're tangible possibilities. Looking ahead, the trend is clear. Public-private collaborations will only grow more essential. As challenges like climate change, resource scarcity, and the need for new frontiers intensify, these partnerships will be at the forefront of innovation. They'll enable faster progress, more efficient use of resources, and the kind of bold, large-scale projects that redefine what humanity can achieve. The question isn't whether these collaborations will continue, it's how far they'll take us. As we look toward the future of living in extreme environments, one thing becomes clear: the boundaries between underwater and space habitats are beginning to blur. Emerging technologies like artificial intelligence, biotechnology, and nanotechnology are not just enhancing these environments, they're fundamentally reshaping how we design and sustain them. Imagine a habitat where AI-driven systems monitor oxygen levels, adjust structural integrity in real time, and even predict potential hazards before they occur. Now, layer in biotechnology that allows us to engineer organisms capable of producing oxygen, filtering water, or even repairing damaged infrastructure. These aren't just sci-fi dreams, they're the building blocks of a future where humans can thrive in the most unforgiving environments. Nanotechnology, in particular, is opening doors we once thought were permanently sealed. Picture microscopic robots or nanobots swimming through the waters of an underwater habitat, repairing cracks in the walls or cleaning up pollutants. In space, these same tiny machines could be deployed to fix solar panels or harvest resources from asteroids. The possibilities are staggering, and the integration of these technologies is creating what some experts call hybrid habitats, environments that combine the best of both underwater and space living. These habitats could serve as prototypes for future colonies, whether they're on the ocean floor or on Mars. But this future isn't something one nation or organization can achieve alone. International collaboration is playing a crucial role in driving these advancements forward. Think about it, the challenges of living underwater or in space are universal, and so are the solutions. Countries are pooling resources, sharing research, and working together on projects like underwater research stations and lunar bases. This spirit of cooperation isn't just inspiring, it's essential. After all, the problems we face in these environments are complex, from maintaining life support systems to protecting against radiation. Solving them requires a global effort where the brightest minds from every corner of the world come together. Yet, even as we celebrate these advancements, we can't ignore the challenges that lie ahead. Building habitats in extreme environments is no small feat. The technology is still in its early stages, and there are countless hurdles to overcome, from ensuring long-term sustainability to addressing ethical concerns. How do we balance innovation with responsibility? What happens if something goes wrong in a habitat miles below the ocean's surface or millions of miles from Earth? These are questions we'll need to answer as we push the boundaries of what's possible. But one thing is certain. The future of underwater and space living is not just about surviving, it's about thriving, and it's a future that's closer than we think. As we dive deeper into the possibilities of living underwater and beyond, it's impossible to ignore the hurdles standing in the way of these futuristic dreams. While the vision of thriving beneath the waves or among the stars is undeniably exciting, the road to making it a reality is paved with significant challenges, some technical, some financial, and others rooted in the complexities of human collaboration. First, let's talk about the technical obstacles. Building habitats that can withstand the crushing pressures of the deep sea or the vacuum of space requires engineering feats that push the boundaries of what's possible today. Even the smallest equipment failure, a crack in a pressure hull, a malfunctioning life support system, could spell disaster in these extreme environments. And let's not forget the unpredictability of nature. Underwater habitats face the constant threat of natural disasters like underwater earthquakes or rogue waves, while space habitats must contend with solar flares, micrometeoroid impacts, and the long-term effects of radiation. These aren't just hypothetical risks, they're real dangers that demand innovative solutions. Then there's the financial side of things. Developing and maintaining these habitats is astronomically expensive. The cost of materials, research, and deployment alone could run into the billions or even trillions of dollars. And who foots the bill? Governments, private companies, international coalitions. The financial burden is immense, and it raises questions about how resources are allocated. Will these projects prioritize profit, scientific discovery, or the greater good? These are questions we'll need to answer as we move forward. But perhaps the most complex challenge of all is the political landscape. Establishing underwater or space habitats isn't just about technology or money. It's about navigating the intricacies of international relations. Who gets to claim these new frontiers? How do we ensure equitable access and prevent conflicts over resources? History has shown us that territorial disputes can escalate quickly, and the stakes are even higher when we're talking about uncharted territories. Geopolitical tensions could slow progress or, worse, lead to outright conflict if not managed carefully. So, how do we overcome these challenges? The key lies in collaboration. Just as the International Space Station brought together nations with different agendas to achieve a common goal, future projects will require global cooperation. Sharing knowledge, pooling resources, and establishing clear regulations will be essential. Technology will also play a crucial role. Advances in AI, robotics, and sustainable energy could help mitigate risks and reduce costs, making these ambitious projects more feasible. And let's not underestimate the power of public support. When people are inspired by the possibilities of underwater and space living, they can drive governments and corporations to invest in these endeavors. The challenges are daunting, but they're not insurmountable. Every great leap in human history has faced its share of obstacles, and the journey to living underwater and beyond is no different. By addressing these risks head-on and working together, we can turn what seems impossible today into the reality of tomorrow. Living underwater or in space isn't just about building the right tools or habitats. It's about solving some of humanity's toughest challenges through creativity and teamwork. And that's where innovation really shines. Whether we're talking about the crushing pressure of deep-sea environments or the vacuum of space, the obstacles are immense, but so is the potential for breakthroughs when people come together. Take interdisciplinary research, for example. It's not just engineers or scientists working in isolation anymore. Architects, biologists, material scientists, and even psychologists are collaborating to design systems that keep humans alive and thriving in these extreme environments. Think about it. A biologist might study how marine life adapts to high pressure, and that knowledge could inspire engineers to create stronger, more flexible materials for underwater habitats. Or a psychologist's insights into isolation could shape the design of space stations to make them feel more like home. It's this kind of cross-pollination of ideas that pushes progress forward. And then there's the power of international cooperation. No single country or organization can tackle these challenges alone. Projects like the International Space Station show what's possible when nations pool their resources and expertise. The same spirit of collaboration is now extending to underwater exploration, with countries and private companies working together to develop sustainable undersea habitats. Sharing knowledge, resources, and even risks means we can achieve far more than we ever could in silos. But innovation doesn't happen in a vacuum. It needs public support to thrive. When people understand the value of these technologies, whether it's for advancing science, protecting the planet, or even preparing for future colonization, they're more likely to back the projects financially and politically. Public engagement is key, and that's where storytelling comes in. By showing how these advancements can improve life on Earth, like using underwater research to discover new medicines or space technology to address climate change, we can inspire a broader audience to get excited about the possibilities. Looking ahead, the long-term implications of these technologies are profound. Successfully living underwater or in space isn't just about survival. It's about redefining what's possible for humanity. It's about creating a future where we're not limited by our planet's boundaries, where we can explore, innovate, and thrive in ways we've only dreamed of. And as we continue to push the limits of what's possible, one thing is clear: the challenges are enormous, but so is our potential to overcome them. As we look toward the horizon of human progress, the possibilities of living underwater and beyond Earth's atmosphere offer more than just a new frontier. They could fundamentally transform how we think about civilization itself. Picture a future where humanity isn't confined to land but thrives beneath the waves and among the stars. This isn't just about exploration. It's about redefining what it means to be human in an ever-changing universe. One of the most profound impacts of these technologies lies in their potential to address some of the most pressing challenges we face today. Take climate change, for example. Rising sea levels and extreme weather events are already reshaping coastlines and displacing communities. But what if underwater habitats could provide safe, sustainable living spaces for those affected? These structures could be designed to withstand environmental pressures, offering a resilient alternative to traditional cities. Similarly, space colonies could serve as a safeguard, ensuring the survival of our species even if Earth becomes less habitable. Resource scarcity is another critical issue that these advancements could help mitigate. The oceans are teeming with untapped potential. Minerals, energy sources, and even food production could be revolutionized through underwater technologies. Imagine farms cultivating seaweed and fish in controlled environments, reducing the strain on terrestrial agriculture. Meanwhile, space exploration could unlock access to rare materials on asteroids or other planets, creating new opportunities for innovation and economic growth. But the implications go beyond solving immediate problems. Living underwater and in space could fundamentally alter our perspective on life and our place in the universe. It challenges us to rethink societal structures, governance, and even culture. How would communities function in isolated environments? What new forms of art, language, or collaboration might emerge when humans are no longer bound by Earth's limitations? These questions aren't just theoretical, they're the foundation of a future where humanity expands its horizons in ways we can only begin to imagine. And let's not overlook the unifying potential of these endeavors. The pursuit of underwater and space habitats could bring nations together, fostering international collaboration on an unprecedented scale. Shared challenges require shared solutions, and the technologies we develop could become symbols of collective progress rather than individual achievement. As we reflect on the broader significance of these advancements, it's clear that they represent more than just technological milestones. They're a testament to humanity's resilience, creativity, and enduring drive to explore the unknown. By embracing these possibilities, we're not just preparing for the future, we're actively shaping it, ensuring that our species continues to thrive no matter where the journey takes us. As we dive deeper into the possibilities of living underwater and venturing into space, it's impossible not to see these advancements as more than just technological marvels. They're a reflection of humanity's enduring spirit. For centuries, we've been driven by an insatiable curiosity to explore the unknown, to push boundaries, and to adapt to whatever challenges come our way. From the first sailors navigating uncharted waters to the astronauts who left footprints on the moon, our history is a testament to our collective desire to reach beyond what we know. And now, as we stand on the brink of inhabiting the ocean depths and expanding into the cosmos, we're reminded once again of what unites us, the shared dream of discovery. These technologies aren't just about survival or practicality, they're about hope. In a world that often feels divided, the pursuit of underwater and space habitats represents something bigger, a vision of collaboration and innovation that transcends borders, cultures, and ideologies. Imagine a future where nations come together to build underwater cities, or where private companies and governments unite to establish colonies on distant planets. It's a reminder that, despite our differences, we're capable of achieving extraordinary things when we work toward a common goal. What's even more inspiring is the potential for these advancements to spark imagination and ambition in future generations. Think about it, children today might grow up dreaming of becoming marine architects or space habitat designers, careers that didn't even exist a decade ago. These technologies have the power to ignite curiosity, foster creativity, and inspire a new wave of problem solvers who will tackle the challenges of tomorrow. And in doing so, they'll carry forward the legacy of exploration that has defined humanity for millennia. So, as we wrap up this journey through the incredible world of futuristic living, let's take a moment to reflect on what we've learned. We've seen how cutting-edge technology is transforming the way we think about underwater habitats, from self-sustaining ecosystems to modular designs that adapt to the ocean's challenges. We've explored the parallels between underwater and space living, recognizing that the skills and innovations developed in one realm can propel progress in the other. And most importantly, we've considered how these advancements aren't just about solving problems, they're about shaping a future where humanity thrives, no matter where we call home. In the end, the story of underwater and space living isn't just about technology, it's about us. It's about our resilience, our creativity, and our ability to dream big. Whether we're building cities beneath the waves or planting flags on distant planets, we're proving that there's no limit to what we can achieve when we dare to imagine what's possible. And that's a story worth telling, one that reminds us all of the incredible potential we hold together. As we wrap up this deep dive into the fascinating world of futuristic living, let's take a moment to reflect on the key ideas we've explored. From cutting-edge technologies like underwater habitats and self-sustaining ecosystems to the bold vision of colonizing space, these advancements aren't just science fiction, they're real possibilities shaping the future of humanity. We've seen how innovations in materials science, energy systems, and artificial intelligence are paving the way for life in extreme environments, turning once impossible dreams into tangible realities. But it's not all smooth sailing. Challenges like environmental sustainability, economic feasibility, and ethical considerations remind us that progress comes with responsibility. The opportunities, though, are immense. Imagine a world where we no longer see Earth's oceans or outer space as barriers, but as new frontiers brimming with potential. These technologies could redefine how we live, work, and even thrive in ways we can't yet fully grasp. So, what does this mean for you? Take a moment to think about how these ideas might shape your own future, or the future of the next generation. Will we see underwater cities or lunar bases in our lifetime? Could these innovations help solve some of the biggest challenges facing humanity today? The answers aren't clear yet, but one thing is certain. The future is being built right now, and it's up to all of us to imagine, explore, and create it. As we close, let's keep this conversation going. What excites you most about these possibilities? What concerns do you have? Share your thoughts in the comments below, and let's keep dreaming big together. The future is closer than we think, and it's ours to shape. Now that we've explored the incredible possibilities of living underwater and beyond, we want to hear from you. What excites you most about these futuristic technologies? Is it the idea of exploring the ocean's depths, or perhaps the dream of building colonies on distant planets? Drop your thoughts in the comments below. We'd love to hear your perspective and spark a conversation about the future we're all shaping together. If you're as fascinated by these innovations as we are, don't forget to hit that subscribe button and join our community. Every week, we dive into groundbreaking technologies, from underwater habitats to space exploration, keeping you informed and inspired. The future is moving fast, and staying engaged means you'll always be at the forefront of what's next. As we wrap up, let's leave you with this thought. The challenges of today are the breakthroughs of tomorrow. Whether it's solving the mysteries of the deep sea or unlocking the vast potential of space, every step forward starts with curiosity and collaboration. So let's keep dreaming big, asking questions, and pushing the boundaries of what's possible. The future isn't just something we wait for, it's something we create. See you in the next video as we wrap up this journey into the future of living underwater and beyond. It's impossible not to feel a sense of awe at how far we've come and how much further we could go. The technologies we've explored today aren't just tools for survival, they're gateways to a new way of life. Imagine a world where we don't just adapt to our environment but transform it, where the oceans and outer space become extensions of our home. This isn't science fiction anymore. It's a vision of what humanity is capable of when we push the boundaries of innovation and imagination. What makes this future so exciting is that it's not just about overcoming challenges, it's about embracing opportunities. Underwater habitats could unlock untapped resources, revolutionize marine science, and even inspire new forms of art and culture. Meanwhile, space colonies could redefine our understanding of community, sustainability, and exploration. These aren't just places to live, they're platforms for growth, creativity, and connection. And let's not forget the human element in all of this. Every breakthrough, every invention, every daring idea is driven by our shared curiosity and determination. It's a reminder that the future isn't something that happens to us, it's something we create together. Whether you're a scientist, an engineer, a dreamer, or simply someone who loves to ponder the what-ifs, you're part of this story. The next chapter is being written right now, and it's up to all of us to make it extraordinary. Thank you for taking this journey with us. The future of living underwater and beyond is no longer a distant dream. It's a horizon we're racing toward, full of promise and possibility. So, as you go about your day, remember, the next great adventure might be closer than you think. Keep dreaming, keep exploring, and who knows, maybe one day you'll be the one to take that first step into the unknown. Until then, stay curious and let's keep shaping the future together.